The first thing here is if you're going to evaluate any functions, okay, using ti89, there's two different ways that you can do this. And so one way is to go into your y editor and just enter your equation directly into the y editor. Okay, so that's going to look like this. So if we go into our y editor, which is diamond F1, okay, and then you can write your equations in any of these equation or any of these y values. So here, negative 3x squared minus 6x minus 7. A couple things on this. Notice it already has the y equals. Okay, and you do need to write it in terms of x. So even if you have an equation that's written in a different variable, make sure you write it in as x. Okay? So a couple things that we can do for this. Now that equation is stored in your y editor. Okay? That means that anytime you use the function notation y1 of x, it actually pulls up that equation. Okay? So you can, if you need to refer to it, you can. And what we're going to do right here is you can use function notation, and since we take that y1 equation and we substitute in a 12, we just use function notation, put the 12 inside parentheses, and it gives us our answer. So our answer here would be this value of negative 511. So I entered it in the y editor, so diamond F1. I entered my equation right here. And then when I go back to the home screen, and I just use function notation, y1 to pull up the function and then put the 12 inside. Okay, now there's another way that you can do this, and that other way is, let's say you just entered your expression the way that it is. So if I took the negative 3x squared minus 6x minus 7, okay, I could also use what's called a width key. The width key is this vertical bar. This vertical bar does not represent absolute values, but if you type an expression, and then you hit this width key, and then you type x equals, or whatever the variable is, you can then tell the calculator to plug that number in for every instance of x in the expression that falls in front of the width key. So I could have also evaluated this by just typing my expression in, width key x equals 12, what I'm evaluating it for, and when I do, it gives me that same answer. So either of those is fine. A lot depends on what else you're being asked, right? So if you're being asked to sketch the graph of it, it's probably best to put it in the y editor. If all you need is just one thing, if you just need to evaluate it, to use the width key is a pretty good and easy way to approach it. Okay, now I'm not going to talk through the steps. I've just included the steps in the notes so you can go back and refer to it. Okay, so I'm just going to demonstrate things. I'm not going to talk through all of the steps, but that is what I'm going to be showing you. All right, so what if what they're asking you is to find the vertex? Now, if you remember how you can use negative b over 2a and then evaluate that, you can do it by hand. I'm just going to show you an alternate way to do this on the calculator. Okay, so if you're looking to find the vertex, what you can do is, again, go back into your y editor. I'm just going to go ahead and replace this because I can. You can continue to build and use y2 and y3 and so on if you want, but I'm going to type my equation in. So negative x squared plus 2x minus 4. Hit enter. So now this is now my y1 equation. What I can then do is go in and view what this looks like on my graph. Okay, so if I hit diamond F3, this little green graph command here, this is going to sketch the graph of this parabola. Okay, and once I'm in the view where I can look at the graph of it, I can find this vertex by locating under this F5 Math tab. So hit F5, and I choose either the minimum or maximum. Because it opens down, that vertex is a maximum. So if I choose maximum, what I'm going to be prompted to do is I'm going to be prompted to identify a lower bound and an upper bound for my x intervals so that I find the highest value, the maximum output between that interval. So as long as I'm to the left of my vertex first, so notice I can scroll left and right along that graph. Notice the little crosshairs here. As long as I'm to the left and below my maximum value, I hit enter to designate my lower bound. And then I can continue to scroll until it starts to go down. Now notice These are the y values. So if it gets to where you're uncertain if something's going up or down, just watch these values right here, the y values, as you scroll through. So here as I scroll, I go -3, gets smaller, smaller, it's about the same. Now it starts, or I'm sorry, gets like higher and higher, higher. It's about the same here, and then it starts to go back down. So once you know that you're below that maximum value, you can set your upper bound. And so I've set it, you can see right here, here's my lower bound. So from here to here, where I set my upper bound, it's going to give me the highest point between them, and that's going to be the vertex. And so it'll post it right there. I see that it's 1, -3, and that would be my answer. Okay. So I want you guys to try that with this second problem here. See if you can do the same thing by typing that into your Y editor, going in, looking at the graph of it, and then scrolling along and see if you can find the max or min value. Just really quickly, let me talk about when you view the graph. If you can't see the graph, if it doesn't look like what I have, more than likely what happened is your window settings have changed. So if you are in the graphing view and you hit diamond F2 where it says window, the default settings tend to be plus and minus 10s for the mins and maxes. So the minimum -10, max X is +10, the scaling is 1, minimum Y -10, maximum Y +10, the scaling is 1. Now we will adjust these here in a little bit when we get to story problems, but this is sort of the default setting for viewing that. So remember the lower bounds to the left of, the upper bounds to the right of. So here, if I was doing this second problem, I go into my Y editor. Again, I'm going to just replace this here. So I have -6 times x plus 4 times x minus 1. So here it is in this form. Enter it. I can go to my graph. It'll sketch what I have. Now, if I need to see where this is located, okay, what I can do is I can start to zoom out on my, my window settings. And so if I hit window, notice on this, I need to go up higher on my Ys. So my Y maximum, to see where that goes, I need to change this. You can change it to whatever you want. I tend to change it in powers of 10. It just makes it easier. Like it's not going to give you the greatest scale all the time. But instead of the 10, I put 100. If it still didn't view in there, then I'd put 1,000, then 10,000. So I tend to use, I adjust my scale by factor or powers of 10. So here I can see where my max is. So I go to F5, my math tool. That vertex is still a maximum, so I choose 4 for maximum. Now I need to set my lower bound somewhere to the left of my vertex. So my vertex is going to be somewhere around here, right? So if I look at these Y values, they needs to be lower than 37. That one is. So I could have stopped right there. I'm just going to exaggeratedly be below my vertex. Set my lower bound. You can see up here where that lower bound set. I need to go somewhere to the right of this vertex. So as I scroll through, I see my Ys are getting higher. Up to here, they're about the highest they'll be. It just went down a tiny bit. Here it went down. So I could stop right here and it would give me that vertex, but once again, I'm just going to exaggeratedly go beyond. I know that between this interval from here to approximately here, the maximum point is my vertex. So when I set that upper bound, it gives me the points as -1.5 and 37.5. Okay. So that is finding the vertices by using the graphs. Okay. All right. Next is kind of answering those same types of questions, but now with a story problem. Okay, so this is one where you may have to adjust your window settings again. I'm going to go back in. Since I changed my Y value, I'm going to change it back to my default settings of plus and minus 10s. Okay, and if I go into my equation editor, once again, I'm going to type in this equation. Notice this is in terms of t, but I have to enter it in terms of x. So I'm going to replace the t with an x, so -16 x squared plus 72x plus 81. Okay, and the question is asking me, after how many seconds does it reach the maximum height? So that's its vertex. What is the maximum height? That's the y-coordinate of the vertex. So x-coordinate of vertex, y-coordinate of vertex. After how many seconds does the ball hit the ground? So now I'll see where the x-intercept is. So if I go ahead and graph these, what I should see is it's not going to fall in my window settings, right? So I can see here that I need to go up higher. My x's are okay, but I need to go up higher to see my y's. So I'm going to go into my window settings, so diamond F2, and I'm going to change by a factor of 10. So my y maximum, I'm going to go ahead and take it back to 100. And then when I view my graph, I look to see, was that enough to see where the highest point was? Still isn't. So I'm going to go back in, and if you wanted to, you can finesse it, right? You can kind of gauge, maybe it's 200, maybe it's 300. Okay, I'm going to go to 1,000. Like I say, I tend to work in factors of 10. It just lessens the number of times I need to view it. And as long as I can see, here's the maximum, I'm good. Okay, so to find the maximum, I'm going to choose F5. It opens down, so I'm looking for a maximum point, and then I'm going to scale. I'm already to the left of my vertex, so the lower bound can be just where it opened up. Scroll until I start going down again. Here's 161, 159, so I've already started going down. I'm just going to go down exaggeratedly more, and when I hit enter, it's going to give me the x and y coordinate of my vertex. So I see 2.25 is the x coordinate. That's how many seconds it's going to take to reach that highest point. And 162 is going to be the highest point. So those are the answers to the first two questions. The last thing I need to do is find this value where it hits the ground. Okay, and so you have a couple options right here. One option that you can do is to stay in your graph, choose F5, and you can hit the 0. If you choose the 0 here, and you want to find, because there's two zeros, right? There's a 0 back here in the negative x's, and then there's a 0 over here to the right in the positives. I want to find this 0. So if I hit the lower bound, so this 0 falls somewhere between, I can just choose where I am right now, and then I scroll until I look at my y's until they start getting negative. Once my y's become negative, there they are. If I stop there, again, I'm going to exaggerate and go a little bit further. But this will give me the 0 that occurs between those two intervals. And so that's where the graph hits, and that would be here at 5.43 approximately. It wants 3 decimal places, so I'll go 5.432. And so that would be my answer. Now, there's a second way that you can solve this, or to find this. How many seconds till it hits the ground? And that is, if we take this function and set the function equal to 0 and solve, it'll also tell us where those x-intercepts are. So if we go back to the home screen, so I hit this home button right here, and if I choose the solve feature under F2, this algebra tab, and I choose solve, and I type in, my equation has already been entered, right? So y1 of x. So this is actually pulling up the equation that I entered in my y editor. And if I set that equal to 0, and then I tell the calculator solve for x, this is going to give me both my negative and my positive 0. The 0 I'm looking for this is going to be the positive one, since we're dealing with a time. Here I'm going to go ahead and put this diamond button so it gives me my answer, displays my answer as a decimal. Okay, and so I get 5.432. So I would get the same answer here. I do have my other intercept is on the negative, but you can't go backward in time. So you're good with just that first one. Okay, so those are your sort of two options. But if you're already in the graph, you can just stay in the graph and find the other answer too. All right, questions on that problem before we move on? All right. The next question is to write in vertex form. Okay, writing in vertex form is going to be based on knowing vertex form looks like this. So if I could find my h value and find my k value, I can plug those in. I will know my a value because it's the same leading coefficient as any of the other forms. So right now, I know my vertex form is going to have an a value of 5, x minus some h value squared, plus some k value. So really what I'm looking to do is find where are the coordinates of my vertex, and I can plug them in here to solve. Okay, so the instructions for this is the same thing that we did previously. So see if you can find, using this equation right here, find the coordinates of its vertex, and then you'll just manually plug those in to these two spots in your vertex form. So to find that vertex, I'm going to type my equation into the y editor. I'm going to go ahead and change my settings back to the normal default of plus or minus 10. And when I graph this, here I see the vertex is located when I choose my F5 math tab. Now this is a minimum value. The graph opens up, so I'm looking for a minimum. And if you can't see, so notice here I can't see where my cursor is, but I look down here, this is the x coordinate, is 0.12. So my cursor is really here. It's to the right of this vertex. So I need to scroll to the left until I see it. There it is. And now I'm somewhere to the left of my vertex. Hit enter, set that lower bound. Scroll somewhere to the right of my vertex. There it is. Set my upper bound, and it's going to give me my vertex here. And notice I have -2, so x minus a -2. And then my 0, or my y coordinate is 0. So I don't need to put anything else there. This would be all I need to fill in that answer. So if you need to reset the window, if you hit diamond F2 to go back to the window, you can then choose it. If you hit this F1 tool, or sorry, if you hit F2 here, you can change the zooms in it. The memory, I think, would allow you to just go to your previous one, or you can store this as your default, and so you'll be able to come back to this when you set it. All right. The next concept in here is to write either the vertex or the intercept form as that general form. And to do this, all you're going to do is use the expand command. Oops. And so the expand command is located, I'll talk through the first one. In this home screen, the F2 algebra tab. Expand is the third option. And then you just type your expression, not the whole equation, just the part to the right of the equation. So -2 times x plus 5 squared plus 2. And then close off the command. One thing to keep in mind, when you look at this, the difference right here where I say -2 times the quantity x plus 5, but this is implied multiplication, right? I didn't explicitly multiply here. The calculator understands going from a number like -2 that the next parentheses is being multiplied. But if you had, like if this had been 2x times x plus 5, it would not understand that this is multiplied. It would give you an error message here. It doesn't know that you're asking it to take -2x times this. So anytime you have a variable and that's multiplied by something that needs grouping symbols, you need to explicitly multiply with the multiplication symbol. Now here, neither of those are actually part of this. So if I go to this set right here and expand, it'll give me my polynomial form, which is -2x squared minus 20x minus 48. And so that would be my answer. Okay, but see if you can do that on this second question. Do the same thing, look to expand the factored form, the intercept form, and write it as a polynomial. F2 algebra, tab, choose expand, and I'm just going to write my factor. So 6, the multiplying is implied after a number, so that's fine. Times x minus 4, also implied, and times x minus 6, also implied. You're good here. You don't have to specifically multiply them. Close off your parentheses, and when you do that, you get your polynomial form. And that would be your answer. All right. Next is finding x and y intercepts. Okay, so again, it is possible for sort of simple types of simple functions or functions with simple graphs that you can go into the graph to look at it. But the easiest thing is to just to find the y-intercept. What you're going to do is you're going to take whatever, or you're going to use the solve feature here, and take whatever your function is, set it equal to 0, and solve for x. To find the the x-intercepts, what you're going to do is, let me go back. I had those backwards. All right, so to find your y-intercepts, what you're going to do is you're just going to evaluate your function for 0. Okay, and that's going to give you your x-intercept or your y-intercept. And then to find your x-intercepts, what you're going to do is you're going to use the solve feature, and you're going to take that whole function, set it equal to 0, and solve for x. And this will give you all of your x-intercepts. Okay? And so the process, what this would look like here, because I'm going to do 2 operations to the same function, to me it's worth my time to go ahead and put that into my y editor. So I'm going to take this equation, x to the 6th minus 41 x to the 4th plus 180x squared. So I'm going to enter that whole, I'm going to enter that whole thing in my y editor. All right, so there it is. Again, just double check, make sure that it's entered the way that you were expecting it to be entered. And now when I go to my home screen, I can evaluate my y-intercept by just taking y1 of 0. This plugs a 0. Now, obviously, you can also do that by hand, right? You see that there is no constant here. When x is 0, y will also be 0. So you're going to see that anyway, so that confirms it. You get the y-intercept is 0. And to find the x-intercepts, what you're going to do is you're going to go to F2, this solve feature, and you're going to take your function y1 of x. Notice we can identify that function from the y editor just by calling it y1 of x. Set that equal to 0 and tell it we're solving for the x's. And when we close this off, it's going to give us all of our solutions. So we see it's plus or minus root 5. And then we see that it's also, notice that we see this little triangle up here. If we scroll up into the display and scroll to the right, we'll see the other answers. So we have 6, we have 0, and we have negative 6. So these would be all of our zeros. For this, I'm going to write these in ordered pair. 6, 0, we have 0, 0, and we have negative 6, 0. So that would be the answers to those 2 questions. Okay, so try the same thing here with this question below. See if you can find the x and y intercepts there. All right, so again, right here, I'm going to go up, change my function in the y1 editor, negative 3 x cubed plus 36x plus 48. And now when I go to my home screen, notice I'm not even going to rewrite anything new. I'm going to use what's already written right here to find my x-intercepts, because it's now changing what my y1 function was. So 4 and negative 2 would be my x-intercepts. And my y-intercept, I can just find, that's easy just to find, right? It's in that standard form. So if I just put a 0 in for each x, I'm left with my constant. But I can also verify it here by entering this same command, y1 of 0, and it verifies 48 as my y-intercept. All right. The last couple things here that you're being asked to do in this section. Remember, this is one where you have this x-intercept at 2, and it wants you to find the other ones. So again, you're not writing the ordered pair here, just the 0. So we know this one. And then we have these other three, that we can find. Easiest thing to do on this is just use the solve feature. Right? The zeros here are when we take this function, set it equal to 0. So if we just write this equation in, and you can do it in the y editor if you want, but since we're only doing one thing to this problem, I'm going to go ahead and just type it in individually. So there's my equation. I'm going to set this equal to 0 and ask the calculator to solve for x, and that's going to give me all of my x-intercepts. And so here, notice I have -1 plus root 3. This is -1 minus root 3. And I have this arrow, so I'm going to go see what else do I have. 2, and I have -3. Okay, and so these would be my answers. Okay. So again, just use the solve feature. You don't, I mean, again, by hand, you need to do something different, right? And that's what you'll be expected to do on your next year. But you can use your ti89s on Monday. All right. Same thing. Exact same thing here, just use the solve feature, right? If you take solve, write this equation, set it equal to 0, and find it, you'll get the same process. So F2 Algebra tab, choose solve, type your equation. Set it equal to 0, comma x tells the calculator what variable to solve for, and when you do, you have your answer 3 and -3/2. Okay, you're not doing the ordered pair, you're just listing your answers. All right, the final thing to talk about is working with some of the discontinuities that we were dealing with. Okay, and so for something like this, what you can do is you can use the factor command. Okay, if you know you need to factor expressions, F2 Algebra tab has an option of factor. And so now these are ones that you should be able to factor by hand, but if it comes to a point where you have more challenging ones, okay, so you get the factored form here of x plus 5 and x plus 6, and do the same thing. Factor the denominator. And So you get x minus 2, x plus 6. What you would then do is you still need to know from this, right? These cancel. The equation of the vertical asymptotes are the denominator factors that don't cancel, so x equals 2. And the wholes are at the factors in the denominator that do cancel, so at negative 6. And so that would be your answer. All right, so this is all I had written there, but there was a request the other day to talk about slant asymptotes. Is there a way to do slant asymptotes using the ti89? So I'm going to show that here really quickly. And this comes in a previous section. Again, we're kind of going out of order here, but when we did the section on the long in synthetic division, this is what I'll talk about when we get to that. But I just wanted to show how you can use it for slant asymptotes too. Okay, so if you just typed in 4x squared and divide by 5x minus 3. So I'm just going to kind of enter that here. 4x squared and divide by the quantity 5x minus 3. If you just type this, nothing changes. It just gives you that expression. So you need something else in order to actually do the long division of this. And the way that you're going to do that is you need to use the expand command. So if we go to the front of this, so I'm just going to use what I've already written. It's already all highlighted. I'm going to jump to the front. I'm going to choose a F2 expand command. Now, I want to jump all the way to the end, and I want to close my parentheses. If you hit second and then either the right or the left, it'll jump all to the end or the beginning of the expression. So second to the right will jump all the way to the end. I can close that off. If I needed to jump to the beginning, I could hit second and this right arrow, and it would jump to the beginning. Okay, but if I use the expand command and do this, what I'm going to notice here is that I have my remainder first. The remainder we can disregard. Okay, all we need to write for our equation of the slant asymptote is this part right here, the whole part other than the remainder. So the slant asymptote is located at y equals 4/5 x plus 12/25. Okay, and so that's how you can find what your slant asymptote and do any long division. Okay, you can just use the expand command as well.